9, 5, tangents. So in all of these we are finding an angle x. We can assume the segments that appear tangent are tangent. And so when we talk about tangents, we want to keep in mind two things. One, well, actually I'm not going to say two things, we're just going to take it problem by problem. So starting with number 1, tangents have a rule that if you have a common point outside the circle and both lines are tangent to the circle, then those lines must be congruent. So right away we can say that 3x plus 4 is equal to 40. Subtract 4, 3x is equal to 36. Divide 3, x is 12. So for number 1, x is 12. Number 2, looking at this one right here, tangents have a property in that they're going to meet the circle at a right angle. That is their rule. So we've got a triangle right here. I've got a 12 for a leg, I've got an x for a leg, I've got a hypotenuse, and it might for a moment seem like I've got two unknowns because I don't know exactly how long this hypotenuse is. You need to be careful because this 8, as is drawn, is only describing C to B. But, like we said on the last one, all radii will be the same. So, here's my setup. Using Pythagorean theorem, because I've got a right triangle, I have a leg squared for x. I have a leg squared with the 12, and that is equal to my hypotenuse squared, x plus 8 for the entire side length squared. Working this on down, you need to be careful because I guarantee you that someone, that pencil has, no, whatever. I'll come over here and use another pen. I guarantee you someone's going to see that problem and say, hey, it's x squared plus 64. And math teachers everywhere cry. Remember, when you are multiplying a binomial, you can't forget about the fact that you have that box right there. Yes, it is x plus 8. X plus 8. Yes, you've got an x squared and a 64, but you also have those other two boxes. Meaning you've got a middle term, an 8x and an 8x means you really have x squared plus 16x plus 64. Oh, look at that. There's more to the problem. And I've got a 144 right there. So at this point, I'm going to move everything over. It doesn't really matter which way you move it. I'm going to move stuff to the right, however, because I like to keep my first term positive. So I subtract the x squared, that stays the same or just cancels. I subtract the 144 over here, and I now get an answer of 0 is equal to 16x. 64 minus 144 is going to be a negative 80. Going ahead and adding 80 back over, I now have 80 is equal to 16x. Dividing by 16 means x is equal to 5. So for that first one right there, or second, we get x is equal to 5. And I kind of took too much space on that, but oh well. We're going to roll with it. I'm now going to jump over to number 3. 3 gets kind of interesting. Let's see if we can make sense of this. So 3 right here, I know that tangents with a common point must be the same, so that means this piece over here is also 3, and that means this piece over here is also 4. What is x? X is both of them combined. 3 plus 4, x is equal to 7. Going over to number 4, let's see where we're at. 60. That's making me think special right triangles. Let's see, we want to find x. So here's the deal. If this is 60, then that must mean this triangle because these pieces are the same as isosceles. So that means that this is 60. But because I know that a tangent line meets the radius at a right angle, that means that this is 30. So then that means that the 6 is across from 60 degrees. So if I focus on that little triangle right there, I now have the following. I have an X, a 60, a 30, and a 6. And we might remember our blueprint that says across from X, or 60, is X root 3. Across from 30, oh, I shouldn't use X. We're going to use Y. Is Y. Across from 30 is just Y, and across from 90 is 2Y. The moment you see 30, 60, 90 special right triangles, I'm doing a horrible job of saying on camera. I apologize for that. So again, anytime you got a 30, 60, 90 right triangle, think of your blueprint. So in this case, across from 30 is Y, across from 60 is Y root 3, and across from 90 is 2Y. That means if I want to get Y by itself, I divide by 3, root 3, so I get 6 over root 3 for Y. Now I could go ahead and simplify that fraction, which I do want to do. So that means multiplying the top and bottom by that square root. I now have 6 root 3 over root 3 times root 3 is just a 3. The 6 and the 3 are going to simplify, and I now have 2 root 3. So I now know that Y is 2 root 3. If Y is 2 root 3, when I plug it in over here, I got 2 root 3. So then my final answer over there for X, I'm now able to say for X that it is equal to 2 times 2 root 3, or 4 root 3. And I promise to pay closer attention that I'm actually on camera, because that's a little messy, but we're going to roll with it. Number 5, let's try and frame this a little bit better. There we go. Okay. 5, what do we got? X is a leg, I got the 4. I know that this being the radius is also 4, which means my hypotenuse is 12. So setting up Pythagorean theorem, I now have x squared plus 4 squared equals 12 squared. Okay, putting that together, I got x squared plus 16 equals 144. Minus 16 x squared is equal to 14, 30, 128. 30, 44, 128. Take the square root of both sides, x equals square root of 128, and we can get back in frame. What's the problem with doing math? You get all like focused and excited and you're not paying attention to your camera. Anywho, we didn't want to take the square root of that. That is an appropriate answer. I want to show the simplified version though to remind you that if we want to simplify our square roots, we break the tree on down. So 2 and 64, and then we're looking for pairs, and by golly, 64 makes a pair, 8 and 8. So I can rewrite this answer with 8 coming out of jail. Remember, buddies break out of jail. And the root 2 stuck behind. And then we got one more, number 6. A lot going on in that picture. Let's see if we can make sense of what's going on. So we got a 12 for the diameter, which means that's a 6. Okay. What do they want us to do? So my mind is going here. I know this is a 4. I don't know that's a 4. I know this is a 4. 2 sides of a right triangle. So the question becomes, if I can find this side, the hypotenuse, then I could just use Pythagorean theorem to find what's left. So let's see what we can do to try to find that hypotenuse. So, or that leg there. What do I know? I know this is 6. I know this is also 6. Oh. I have no idea if this is the right way to do it or not, but this is what I'm going to do. I'm going to recognize I got a trapezoid right here, right? Because these meets at a right angle. Ooh, do I know this is a trapezoid? I want it to be a trapezoid. Because if it were a trapezoid, and that was 90 degrees, do I know that that is true? Doesn't say that lines are parallel. Oh. It's the last one on each of these pages, apparently. Let's think for a second. Okay. I want it to be 90 degrees. Is it 90 degrees? I know we can't assume. Let's see. So, because what I want to do is I want to say, let's find this right here. And because this is 6.4 and this is 10, I know that what's left, squiggly part, must be 10 minus 6.4 or 3.6. And now that I've got two sides of a triangle, right triangle, I can find the third side, which is my x. However, I'm not 100% certain that we can say that that is 90 degrees. I know this one is, but I don't know about that one. So if I were to ignore what I just talked about in red, I drew in a radius there for 6. Is that the only thing that's going to help us? Let's see. Oh, I wonder if it's like a distance from the center problem, isn't it? I was doing so well, and then I got kind of stumped, and now this is taking a little long. Okay. Is there a way that I can make the claim that this must be 90? Let's think. So this is tangent, meaning this is 90. I know this and this are 90. But there's nothing saying that this one over here couldn't be slightly askew. So my argument here about the 3.6, as much as I want to do that, I can't. Unless they told me that these two lines are parallel. And it just says lines that appear to be tangent are tangent. So the only one I know for certain is this Q. Oh! I'm dumb. Okay. So, I added in this right angle right here, right? Okay, so I want you to look at this first triangle. I'm going to outline the whole thing in yellow. Yay for highlighters. Boom. See that guy? We got a right triangle in yellow. And that right triangle in yellow has the following dimensions. I've got a radius of 6, and I've got a hypotenuse of 10, which you might recognize as a glorious 3, 4, 5 triangle that is scaled up by 2, which means I automatically know that the remaining leg must be 8. If you did Pythagorean theorem, that's fine. Now that I've got that triangle, And just to be clear, this 8 is segment QC. Well, now I can take QC and that triangle in orange, in which case I know my hypotenuse is 8, and I know QD is 6.4, and I want to find x. And now I do need to use Pythagorean theorem. So I'm going to go with, I'm just opening up my calculator because I don't want to do it by hand. Settings, calculator, and I've got, what do I have? I've got 64 minus 6.4 squared, and then that gives me x is equal to the square root of 23.04. So when I take the square root of that, I get a final answer of 4.8. Which I'm curious if that's going to check out to what we had before. So I'm actually going to try that just for funsies. So if I go back, my previous one would have said 36 minus 3.6 times 3.6, and then it would have taken the square root of, yeah, same thing. So it would have worked out this way. However, in doing that, we would have assumed the extra right angle. So I like this approach with the two triangles better. So I apologize for that slight delay, but hey, you got a glimpse of the way my mind thinks. Anyways, colors can be helpful.